Yeah, so it looks like things are still broken here with the instances, but I'm going to go ahead and do one of the challenges that one of my teammates solved already, which is under general skills, repetitions. So can you make sense of this file? Download the file here. Go ahead and copy this link address, and we're going to hop over into my Kali box. Let's go to PicoCTF. Let's go ahead and create a new folder, and we'll call that repetitions. Hop in the terminal. Go ahead and blow this up. And we are going to change our directory into the repetitions. It's an empty directory right now, but we're going to use the wget command to download the flag file here. All right, now we should have that file in there. Let's see. Let's go ahead and I wonder if we can just run strings on it. Yeah. Hey, just me from the future. So the strings command, let's talk about what it does. The strings command will go through and it pulls out all the plain text from a file. It's typically used on like a binary file, or in this case, I'm using it on like an encrypted file, and it's going to pull out anything that's not anything that's readable, right? So it's not going to pull out like hex values. It's not going to pull out binary bits, but it is going to pull out plain text strings. And that's what we see here. So to me, this looks like base 64 because if we look there, we can see that there are two equal signs at the end. You know, the reason why we have those two extra characters of like padding on the end is because our base 64 string length has to be divisible by 4. If not, the decoding doesn't work, right? Because base 64 deals with the sets of 4 characters there. That's all. If you see one or two equal signs at the end of a character string, it is likely that it is encoded in base 64. Strings, and let's put that into a text file called base 64 flag .txt. And then let's output our base 64 flag text and go ahead and pipe it into base 64 decode there. So it looks like that didn't seem to work how I had wanted it to. All right, that's fine. I just wanted to say that totally worked how I wanted it to. I just didn't read properly. So like what we could have done is we could have just continued piping or going back to that last command and then piping that into another base 64 decode until we got to our final value, or we got to the point where we no longer needed to do base 64 decode and needed to do some sort of some other operations on it. Let's actually just go ahead and try this instead. Let's copy that. Let's go echo. Paste that in. And then pipe that in through base 64 decode. So we did get something else out of there. Not quite sure. That looks like it could possibly be more base 64. So let's go ahead and take that same command and then put it into another text file called base 64. Oops, base 64 stage 2. .txt. All right, let's go ahead and take our base 64 here. Yeah, and at this point, it's really just me repeating the process over and over again, so I'll go ahead and speed up the video here, and yeah, just so you can see the end result. Have our string here, copy it again, put it in, and again pipe it through. Hey, there we go. It wasn't too hard, just a little tedious. And just so I can keep track, we're going to put that in a text file called decoded flag.txt. Let's go ahead and copy this over. And we'll come over here, put it in, and see if that worked. Hey, there we go. So, even though that didn't do anything for my team, at least it's some, the completionist in me likes seeing the extra green check marks there. Hey, thank you for watching. I'm going to try and put a video out for every one of the challenges that I solved during PicoCTF 2023. So if you just want to see how someone else ended up approaching these problems, just keep an eye out. Thank you.